not a fast structured logging package, so I'm sorry to disappoint for anyone who is expecting that. I am going to talk about advanced concurrency techniques and basically just features of the sync and x/sync packages. Before I get into that, let me start by introducing myself. My name is Yarden. I'm a software engineer at Rookout. I really love learning programming languages. So in my day-to-day, I get to jump between like 6 or 7, which is pretty cool. And also their internals. And I am an amateur sewist. I like to sew occasionally in my free time. Woohoo, sewing. Yeah. I'm really, really excited to be here, as you can probably tell. But we'll get comfortable. We'll become friends by the end of this talk, I promise. And as I said, I really love learning programming languages. And as you can see, like there's really 7 languages here. And I really do all of them in my day-to-day. And something I get asked quite a lot is, like, what's better, Go or Rust? And first of all, that's a stupid question because obviously Go, right? And secondly, that's a stupid question because I don't know Rust. But, like, the answer is always going to be it depends, right? Because, like, I don't know, if you're going to write a short script, do that in Python. If you have a team of really talented Java developers, use Java, right? And each language has its really main characteristics that like come forward when we have these discussions. And for Go, the biggest thing for me always is concurrency. I think there's 2 main reasons for that. First is there's built-in support for Go routines and channels, and they're not only like part of the standard library, but they're in the language. Like it's part of the syntax. If you've written an entire Go program and it doesn't have like one Go routine running, like more than one Go routine running, that's kind of weird, right? Like why'd you use Go? Well, except for the fact that it's a great language, besides that. But you're probably going to use more than one. It's built into the language. It's so easy to use. And the second is that Go routines are lightweight threads, right? That means that ahead of time, they thought about this. They were like, OK, we don't want to do like the full thread thing that's going to take memory and time to open and stuff like that. People have to really think if they want to open a thread. No, Go routines are so much lighter and easier to use. And then we can use channels to send data between them and stuff like that. Really, really awesome. But it doesn't just stop there, right? There's other things written by the Go team or as part of the Go project that help us synchronize our concurrency programs. And those 2 are sync and x/sync. So sync is just part of the standard library. You've probably used it already in your code. And x/sync is part of the X packages. And what X packages are still packages written by the Go team or maintained as part of the Go project. They're just not part of the standard library, so you're going to have to do go get and then the name of the package. But except for that, they're maintained, they're stable, like almost the same as the standard library itself. And I was really interested in these packages. They have a lot of features, and some are more well-known, and some a little less. This is a partial list of the features that aren't written here we're going to talk about. So if you know all the features, and you can tell from this list, that's impressive. And let me just say like a few words about each feature. We have mutex, mutual exclusion lock, right? You can lock, you can unlock. If someone's taken the lock, you'll have to wait for it. We have once to just run something one time only. We'll have a pool to create a memory pool. This is to save on allocation, so it's going to be a pool for long-term objects and not short-term objects. We have RW mutex, which is like a mutex, but it's a lock that allows for several reads, but only run write. For a map, that might be good. We have WaitGroup, which will just wait for a group of Go routines to finish. So if we have a task and we want to split it, run it concurrently, right? Split it into subtasks and run it concurrently, we can have our primary Go routine wait for all the task Go routines using WaitGroup. We have a semaphore, which is a weighted lock. And we have a sync.map, right? It's not the regular map. It's a concurrent, safe implementation of map in the sync library. Cool. Right? Awesome. And before I even tell you what feature we're going to talk about first, let's start with an app. OK, we're going to have a file transfer app. We're going to want to transfer each file we get to multiple destinations. Now we have a file struct and we have a con interface. The con is going to be our destination. We're going to use it to send the file to our destination. So it'll have the send method, which accepts a context and the file to send, and it'll return an error if it, for some reason, fails to send the file. Cool. So what do? We have to implement the transfer file function. Now, as you can tell, it's not really transfer file specific. This is more to show the implementation of the concurrency part of this program. So if we do that with wait groups, we can do it pretty easily, right? We'll just create a wait group. We'll iterate over our connections. We'll add one for each connection because we want to wait for another task to complete. We're going to create a closure, right? Iska mentioned this, that because of the way for loops are, if we don't capture the variable, it's going to always be the last variable from the cons array. So do that, important. And then we're going to send the file over the connection, and once that's done, we're going to call the done method. Pretty cool. In our primary Go routine, we'll just wait for all those connection sends to finish. Cool. But if we look back at the signature for the send method, there's something here that we totally just didn't give any attention to, and that's the error that's returned from send, right? Like, we didn't log it. We didn't do anything with it. And I don't just want to log it. I want to return it from transfer file. So I want to propagate it up to the caller of transfer file. And for this, we have error group. While wait group and error group are very similar, they're used for similar cases, but error group has a few additional features. So while with wait group, we'd have to add for the number of tasks we want to wait for, and then call done for every task we've finished. In error group, we just have to call go with the task we want to run. So we don't run the task ourselves. It will run it for us in a separate Go routine, and it will also stop once we've reached an error. If we've returned an error, it will return that error from the wait method. Okay, so both have wait. Wait groups wait, we'll just wait. Error groups wait, we'll wait, but also return the first error that's returned from any task. Now, just a general example, for wait group, we're just gonna, for to run a task n times. With wait group, this is how we're gonna do it, right? We're gonna add n by the number of tasks we need, and then just call that task in a loop. In error group, the syntax is even shorter, and I think it's even more clear what's going on here, and we can also use the error in the end. So let's integrate that into our file transfer app. Instead of a wait group, we'll create an error group. Once again, we need that closure to capture the con variable. And then we can just call the send method and return the error returned from it. Now, when we call wait, we can return the error returned from wait to the caller of transfer file. So at this point, we have error propagation, which is already a big step. Like, we didn't have to use channels. We didn't have to use anything. Error group managed that for us. But there's another thing that we're missing here, and that's the use of context, right? We use context in order to be able to say, stop this now, right? We'll have the send method, which I don't know how long it takes, but if context is finished, or if context is done or canceled, we'll want the send to stop immediately and not to finish sending. Now, I want to use that so that if I have an error, I'll just stop the send in its tracks. I'll stop the send immediately on every single connection. Fortunately for us, error group also has this feature, which is called with context. Now, first thing we're going to notice is that it returns a new group. So we don't have to create a group just using the struct creation syntax, but we'll call with context. And the second thing that we can notice is that it accepts a context and it returns a context. So the context it accepts, it's going to wrap it in a new context, and the new context it returns is going to be canceled if an error occurs. Okay? So what we can do next is, instead of creating an error group just with the struct creation syntax, we can use the with context method, get that new context that's created, and pass that to the send method. That's such a small difference, but now we're saving on resources and time, I don't know, CPU, performance, memory, everything, because we're stopping the send once we have an error, because we don't want to continue sending. So it's pretty cool. Error group has more features, for instance, set limit, which will set the maximum number of Go routines running at once. Now, that means that it changes the use of Go, because Go will now block until if we reach the limit of Go routines available to run, then Go will block until it can run and not reach that limit. But try Go will not block and just return false if it's unable to run because it's reached the limit. So we can use that. If we haven't used set limit, like in our example, it won't matter. It won't change anything. So that's the first feature I really wanted to talk about. And the next feature is Singleflight. How many of you have heard of Singleflight? Interested? OK, there are a few hands. That's cool. Just so you know, it's imported by 1,215 projects. I don't know if that sounds like a lot, but AirGroup is imported by about 12,000. This is true to today, by the way. It's 8 more than it was last week. But AirGroup is imported by 12,000. And I'd still consider that a pretty niche feature of the sync package. So that's not a lot at all. What's interesting is that the Golang repo has its own internal copy of Singleflight. Obviously, like the Golang source code can't import any external packages, right? That makes sense. So it doesn't import Singleflight, but it has its own implementation of it. It's pretty similar to the to the Singleflight implementation, with a few differences. And basically, what Singleflight is a duplicate function call suppression mechanism. And that's a lot of words that to me mean basically nothing. So let's get into it. We'll forget about the file transfer app. And instead, we're going to create a token authenticator app. And for that, we have a token interface with an authenticate token method, and which accepts a context once again, and a token. And given that token, it will do its authentication. It might take a long time. It might take a little time. I don't know. It'll do that authentication, and it'll give me some sort of response, a Boolean, whether it exists or not, so whether it's authorized at all or not, and then an error if an error occurred while authorizing. Okay, now the response will include everything we need to know about the authorization, not really important for our implementation, but things like, I don't know, which users are authorized, more specific nitty-gritty details that we don't need to know. Another thing we already have implemented is a cache. So we'll have a cache record, which will hold the response. This basically holds exactly what was returned from authenticate token, right? The response, whether it exists, and an error if an error occurred. Now we'll have an interface for our cache, which will just get the authentication status or the cache record for a certain token, set the token with a certain time to live, so after that time the token will be removed from the cache, or just remove it manually using the remove method. Now, what do we do? Well, we want to implement a cache token authenticator. A cached token authenticator. So we want to take both of those. We have an authenticator and we have a cache, and use them, manage them, basically, right? We want to use the cache if it's available in the cache. If it's not, we want to call the full authentication function. So how would we do that? Well, first, we're going to check. I'm sorry, I forgot to say that. For this, we'll have both an authenticator and a cache as part of our cached token authenticator. I'm going to say CTA for short from now on, because cached token authenticator is hard to say many times in a row you try it. We're going to implement the authenticate token method for our CTA. Cool. So the first thing we'll do is just check if the record exists in our cache by the token we're given. Pretty straightforward. Now, if it doesn't exist, then we're going to call the authenticate token method on our authenticator. And with the response, we're going to set it back into our cache so that the next person that tries to authenticate with the same token will already have a cache hit and won't have to call the authenticate token method itself, and then just return the response that we got. Cool. But let's think about this situation. Okay, for some reason, I'm calling authenticate token twice with the same token at the same time. And the authenticate token, I kind of wrote the flow of the function just so we can kind of visualize what's happening, right? First, we check cache. If we have a cache hit, we can immediately return a response. But if we don't have a cache hit, we'll authenticate and then add to cache. And for our simulation, this is the first time we're trying to authenticate token with this token that's given to auth twice. So we have these two numbers, and each is going to represent its own authenticate token call. Now, let's say the first one starts running, right? It'll check the cache. Do we have a cache hit? No, yay. Great, we don't have a cache hit, so it's going to start authenticating. Now, authenticating takes time, okay? And while it's authenticating, number 2 will start, and it'll check cache. Checking cache, short, really, really small operation. It's not in the cache. And now both are authenticating. And that's taking time, it's taking resources, right? If the authentication uses network, we're using more network than we need to. And in the end, they're both going to add to cache, again, something that's not necessary. And they're both going to, at the end, just return the same response, right? The response hasn't changed at all. For this, we have Singleflight. Now, what Singleflight does is it's a duplicate function call suppression mechanism, which means that given a certain key and a certain function to get the value for that key, right, we have a key value cache. So to get the value for that key, it will only run the function once every single time, okay? And that's a little complicated, so let me show you what that means. First of all, we can see that it's a method on the Singleflight.group, so we have to create that and then call the do method on it. And then it's going to get a key and a function. And this is just a generic example, has nothing to do with our CTA. But the do will just call some sort of method or function to get the value for that key. And why is this interesting? This means that once we've started this function with a certain key once, and until it finishes, then Singleflight will make sure that it doesn't start again with the same key. Okay? So if we go back to this, then what will happen is while 1 is authenticating, if we do use Singleflight, then 2 will start and check cache. And if our authentication is part of the Singleflight's mechanism, then it will make sure that 2 does not authenticate at the same time. Just wait for the first authentication call to finish. Okay? Once the first authentication call will finish, because it's the same key, it's the same token, it'll just get the response from that. So once again, that's the key, and then the function, which will return the value for that key. And there's a few things that are returned. First of all are the interface and the error, which are just returned from the function that we passed. No changes will be made, no additional errors, nothing. And the last thing is a Boolean, whether this response is shared between multiple calls or not. In our specific case, and for most implementations I've seen, we don't really care about the response, whether it's shared or not. But I don't know, you can access that if you want. And so what we can do is just get the value and their error like this. Now, our code is going to do the same thing, right? It's going to look the same way. But in reality, when we do those calls 2 times at the same time, only one of them is going to actually do the function given to do. So let's see. Now we need to add a group. In order to use this, we're going to add a group to our CTA. And we're going to use that group here. Let's break it down. First of all, we're still going to check if it exists in the cache, right? Makes sense. Second of all, we're going to call the do method that we just saw. Now, what's going on inside the function that we're passing to the do method? Well, first, we're doing the authentication. And we're also adding it to the cache, because adding to the cache is something that we want to do once. We don't need to do it more than once for the same key, as long as the key exists. And this is something a bit weird, because we never return an error, though our authenticate token method can return an error. And the reason for that is that the record itself, I don't know if you guys remember, but the record itself had an error in it. So instead of just sending the error separately as another variable, the record will hold the response, whether or not the authentication worked, and an error if an error occurred. So we'll just return that, and we can kind of discard the error variable. And as such, we're also only going to take the first variable returned from the do method. Now, the do method returns an interface, so we're going to have to convert that or cast that to a cache record, because we know it's going to be a cache record. It always does the same thing. And we're going to return all 3 of the fields from the cache record. So just by doing this, like once again, we did almost nothing. We just added this do method around our authenticate token call and our cache set. We're saving on memory. We're saving on network. We might also be saving on time. I think this is really cool. I was really surprised that only 1,200 packages import this. But yeah. Now, once again, we're just missing out on a key part here, which is the context, right? Both the token interface and our authenticate token function accept a context. And when I see a function that accepts a context, it's not there for fun, right? It's supposed to mean that my function will stop once that context is canceled. And if we look back at our implementation, we don't do anything with the context. It might as well not be there. So not only is this just like we don't need the context variable, but it's kind of misleading to have this function signature, if you ask me. So obviously what we're going to do is not remove the context, but actually take it into consideration and check if it's failed. Now, for that, there is the DoChan method on Singleflight. So we talked about the do method, and the DoChan method is almost exactly the same. They accept the same parameter, and they do the same thing, right? They'll suppress another call to the same function for the same key at the same time. But the difference is in what they return. While do will just block until the function it's called has completed, and then return the results from that function, the DoChan will immediately return with a channel, and that channel will receive a response. And response has the exact same thing that do returns, right? It'll have the value and the error and the shared boolean. So what we can do here is the same thing, right? We're going to check the cache, and then I kind of wanted to shorten this, so I just added those comments. But we're going to check the cache, and then instead of calling do, we're going to call DoChan and do exactly the same thing inside that function. But we're going to get a channel back. And then what we're going to do is call select. And what will happen here is the first of these 2 cases will be the one that is called, right, or entered. So what we're going to do is wait for the result from C, which is like the happy flow, right? Most times what is going to happen is that we're going to get that result from C. But in case something terrible happened and our context has been canceled or is done, then we're just going to return the error returned from context and return nil. Once again, the happy flow will just return the correct record that we got. Pretty cool. Singleflight does have a few another feature, which is to just forget a key. Again, this is all happening at the same time, right? So if I have 2 calls to the do method, one after the other, not in parallel, not concurrently, but one after the other, then Singleflight will have no impact on my program, only at the same time, which is why we also use a cache or a map, usually alongside Singleflight. But if I wanted to forget a key or force Singleflight to forget a key, I could use the forget method. Also, Tailscale has their own or not their own, but they have a wrapper, I think, for Singleflight, which allows for generics. So that's also pretty cool. If you use generics, you should use that. And one last feature I sort of wanted to talk about is Cond. Who did that? I'm going to disappoint you now. OK, so Cond, you can kind of think of Cond like a lock. And it has that wait method, which will cause a go routine to wait for something to happen. I'm purposefully starting with that because that's an easy way to think about it. We have one go routine waiting for something to happen. And then we have another go routine which can signal that something happened. And they can either signal to one single go routine, but not a specific go routine that thing happened. Or it can signal to all go routines waiting that thing happened. And if that wasn't really clear, that's fine, because as it states in the Go documentation itself, for many simple use cases, users will be better off using channels than a cond. Specifically, broadcast corresponds to closing a channel, and signal corresponds to sending on a channel. And I even think that this thing in parentheses actually makes for a better explanation of what cond does than actually explaining the functions, because you can kind of see it as channels that we're already familiar with. And they don't only say that, they also say that for more on replacements for Sync.Cond, see and give 2 talks that you should see instead of that. So I was going to talk about cond. I think it's an interesting feature. There is uses, there is imports, but I really don't want to encourage anyone to use it. That's why I'm sorry to the person who did woo, and I'm sorry to you. But if you think you have a very, very specific situation where this can help you, definitely check it out. OK. Now, which I actually talked about all the features of the sync and the x/sync packages here. So thanks for being my audience for that. And I did want to talk a little bit about why I'm even talking about this, why I think it's interesting, why I think it's worth spending 30 minutes of your time. And the reason for that is that it's really hard to reach these things by yourself. Like, I just randomly kind of woke up and was like, oh, I wonder what sync features are out there. But without that, I wouldn't have gotten to these features. So I did want to say that if you're into discovering new packages, especially written by the Go team themselves, like that feels so special, package.go.dev is the first place I look. So if I need something that might have already been implemented, that's the first place. The next place is going to be github.com. I don't know. I'm guessing most people just Google search, so I don't. I go to these specific websites. The next thing is that there's a lot of things in the standard library, and you might not even know about them. Like, there are the more common ones, right? Time.time and stuff like that. But like even AST, which is to like parse the Go syntax, it's part of the standard library, so you're going to have it anyways. So you should check out packages over there. And for the X packages, also tons of cool stuff there. That's the site where you're going to see the whole list of them. Another thing is that, as I said, Singleflight is only imported by 1,215 packages. That's not really the interesting part here. The interesting thing is that if I click on imported by right here, then it'll take me to a list of all the packages that are publicly available that use Singleflight. And why that's interesting is because the cache token authenticator isn't something I made up. I did not want to come on a stage and say cache token authenticator 20 times. That was not fun. But the reason I took it and used that example is because it's the exact code, or almost the exact code, as a Kubernetes implementation of a cache token authenticator, which you can find here. There's the barcode that will lead you there, too, because I'm technological like that. But yeah, it's so cool, because I was just like, oh my god, who even uses Singleflight, right? This is super specific. 1,000 people use it. Like, it's nothing. But then I kind of looked at the people who are using it, and these are people with really heavy Go usage that really know what they're doing. And I could even look at this example and understand from it why it's useful, where I would want to use it. I read this, and I realized that I would probably use it in every cache implementation I would probably ever do, because it'll save time and it costs me basically nothing. So that's really cool. And thank you so much for your time.